Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Epoch Learning Center Project 13. This is actually going to be, there's going to be two pieces of software for this project, Project 13A and 13B. We'll talk about that a little bit later. This is called Multiplexing, the 7-segment display. So now, we're going to create a 5-minute countdown timer using all 4 digits. If you haven't seen the 7-segment display video, check it out. It's our most previous video, and that is going to talk about our initial discussion on the 7-segment display and the original hookup. For this video, or for this project, we just need to hook up 3 more lines. In the previous video, we're only controlling the rightmost segment. We're connected to control segment pin 1. So we need to populate control pins 2, 3, and 4. And so let's do that now. Currently controlling segment control pin 1 is GPIO pin 10 on chip A. So we're going to connect GPIO pins 11, 12, and 13 to control pins 2, 3, and 4 respectively. So I'll do this with the video on. GPIO 11 on chip A to control pin 2 for the 7-segment display. I know it's difficult for you guys to see. However, if you have an Epoch sitting in front of you, it'll all make sense. You'll be able to see it with your own 2 eyes. And so, GPIO pin 12 to control pin 3. And lastly, GPIO pin 13 to control pin 4. And this is all we need for Project 13. Project 13B needs one more connection, but we'll talk about that a little bit later. I'm going to get this connected, and then I'm going to start the video back up. Okay, so I've uploaded the program. I'll power it up, and what we'll see is a 5-minute countdown timer. Now, you see how it's blinking? To the human eye, the countdown timer looks perfect. But because I'm using a camera, it's picking up what's happening actually more reliably than the human eye. What's happening is we are turning each of these digits on and off 50 times a second, each of them. So how this is working, what's happening is each segment has its own data. As you can see, this is, like, for instance, 8 right now, 2, 4, and 0. It's got its own, it's on its own storage register. And what happens is we turn this digit on for 5 milliseconds, update it with, we turn it on, we update it with its current number, we wait 5 seconds, we turn it off, then we turn this digit on, update it with its value, wait 5 seconds, then turn it off, and do the same for this digit and this digit. Only that entire sequence happens 50 times a second. Now, with a delay of 5 milliseconds for each display, that's 20 milliseconds that it takes to do one cycle. Multiply that by 50 and you've got 1,000 milliseconds. And so it updates 50 times every 1 second before the number changes, before the numbers decrement. And there's a lot of decoding involved in the code, which is why it's very diligently commented. There's a lot going on with this code. So what we can do is there's several numbers in the code that will allow for us to manipulate how fast this countdown timer goes. We can update the amount of time on the timer, and I'm casting a shadow over top of it because, again, using my eyes, I can see this countdown timer. It looks brilliant, but to the camera, it looks finicky. So before we go on to Project 13B, I'm going to, on the fly, change some of these numbers, and we're going to see if the camera notices it. That's much better. So what I did was I just changed the software, and it'll actually be the software that you see. It looks much cleaner now to the camera. It still looks the same to my eyes, but the camera isn't noticing it as much because what I've done is I've made it so that each segment is on for only 1 millisecond. So for one cycle, it takes 4 milliseconds to scroll through the data. We multiply that by 250 times before we decrement the clock data. So 250 times a second, this is changing. Being turned on and off and on and off, and I multiplied that by a total of 4 milliseconds by 250, which again gives us 1,000 milliseconds. So every 1,000 milliseconds, every second, the timer data decrements. And so now it looks much better to the camera. So you can play with those numbers. I can make it count down much faster on the fly if I want. by changing 250 back to 50. So we've got 50 seconds multiplied by 4, so every 200 milliseconds now after this updates, it'll start counting down. So this is going to be a very fast countdown timer now. So in the code, I want you to go through and I want you to play with it. I want you to tinker with the numbers. I want you to see this. Now what I'm going to do is I'm going to hook up the variable resistor, pot A, potentiometer A, and I'm going to connect it to one of the analog pins, analog pin 3, on chip A. And what we're going to do is, do you remember the video? If you haven't already checked it out, check it out. I think it was project 6 or 7. It was variable delays with the variable resistor. What I'm going to do is I'm going to use the variable resistor to make changes to the delay so you can actually see the multiplexing process. Stand by. Before I do that, actually, I want to show you what happens when time runs out with this code. When all data reaches 0, it starts back at 5 minutes. That's how I programmed it. You can try programming it so that when time runs out, you light up an LED. Use what you've learned so far and manipulate the programs to work for you. We'll experiment more with this in later videos. Again, I wanted to make a Hollywood-themed bomb prop project much later. But yeah, so fudging the numbers and playing with it, when all 4 data segments, the integers containing the segment data reach 0, there's a function that says, are all of them 0? And if so, do this. Look for that function in the code and make changes to it. Now what I'll do is I'll connect the pot A output to analog pin 3 on chip A. So this is through project 13B. The analog value from pot A is between 0, the analog to digital value rather, is between 0 and 1023, and we're using that as the amount of milliseconds in delay between turning each segment on and off. So I'm placing my hand here because the lighting in the room doesn't appear to please the camera, but I'm going to start changing. I'm going to start turning pot A right, and that'll slow it down because the value is closer to 5 volts, and so as you can see, it's starting to slow down. And if I turn it left very slowly, we're going to start seeing it go so fast that it's going to create the illusion that all of them are on at the same time. And that's multiplexing. Right there. And now it's going to start counting down at about 1 second. I could tune it. This is why you want to set the amount of you want to set the numbers in software if you want a fast countdown timer or a slow one. But this one's neat because now I can actually show you the digits turning on and off. So that's how multiplexing works. I hope that makes sense to you. I realize that I ramble a little bit sometimes, but the code is fully commented, and there's 2 different pieces of code. This 13B has just a little bit of change. It's the changes are surrounding the pot and how we're using that to adjust the speed here. So thanks for watching. Project 14 is on the way. If you haven't already checked out the Kickstarter, it's linked below. Thanks again and have a great day, everyone.